Modern implants can substitute or support physical functions of the human body for a person who lost this due to an illness or injury. Damages are repaired or disease symptoms alleviated by their use. Implants can be used almost anywhere in the body. One problem is the limitation of human tissue and synthetic materials. There can be undesirable negative reactions by the tissue to the foreign body. Professor Martin Möller from the DWI, the German Wool Research Institute of the RWTH Aachen University, explains how functionalization of implant surfaces is meant to influence the body's reaction. Surface functionalization always means depositing a thin layer onto an implant surface that needs to contain specific properties. The body is meant to recognize this layer versus the actual material underneath. Implant surface functionalization is needed to trigger and cause a preferably favorable response by the body in which the implant is being installed. An implant contributes to treatment success but presents the body with difficulties when it comes to the self-healing process. Scar tissue can form after implantation and restrict implant function. Our primary path is to deposit thin hydrogel layers onto the implant surfaces, to where the implant surface is highly hydrophilic, that is to say watery. This way, the body recognizes it as less of a foreign body than a hydrophobic surface. This is, for instance, found with traditional synthetic materials that are inserted into the body unmodified. The DWI is part of the National Remedies Research Network. The network researches the functionalization of microimplants, such as stents for the use in the vascular system, eyes and middle ear. The DWI develops intraocular lenses. We are partners in the Remedies Research Network in the development of an adaptive lens. If the eye lens is clouded, known as eye cataract, you often remove the eye's lens. The best available technology is to insert a hard artificial lens at this point, which is not adaptive, however. Instead of developing a hard lens, the DWI researches silicone, which is directly injected into the capsular bag during eye surgery. This material is flexible and is not toxic in the body. What's more, it promotes osseous integration. Our assignment is to modify silicones to where they are no longer hydrophobic and thus cause uncontrolled cell proliferation again due to residual epithelial cells. They should be hydrophilic instead and prevent new cell growth. In the case of such complex implants, surface characteristics will presumably play an ever-increasing role in the healing success. The future development of surface technologies will be more and more geared towards biological functionalization of the surface, so that the cells that make contact with the implant recognize the surface almost like an organ.